All of you note the question. What is the way they will ask you the question here? Suppose if it is if they want to ask you like a CBQ level, they will ask you the question. Give a oxidation reaction where we can get a sulfides as a product, like metal sulfide as a product. So that they are not even mentioning corrosion reaction. If it is corrosion means immediately you people can remember, okay, it is a, but they are asking oxidation reaction. Corrosion reaction is a what reaction? Corrosion reaction is a what reaction? It is an oxidation reaction.
Okay.
Right or wrong? All of you. Yes, please respond. So that is what. Now they are asking, it is a sulfides. So in corrosion, sulfides means what? We all know that. If it is oxides, iron. Sulfides means what metal? Anybody?
Silver.
Sulfides means silver. And if it is carbonates means what? Copper. Keep in mind, whenever corrosion or oxidation, sulfides means it must be a silver metal. Oxides means definitely it is iron metal. Carbonates means it is definitely a copper metal. Only 3 equations you have for entire 10th. So whatever the way they ask you, please attend it and write it properly so that you all people can mix. So just is very simple. So whatever the way they ask the question, whenever I mention that this is the way they will ask the question, so you have to write it there so that there is a possibility of asking the question. 100% we can expect it. That is what you have to make it. Clear, guys? Yes?
Yes, sir.
Now, so as I said, all the metals are luster in nature, and there will be appearance. You can see metals are lustrous. That is what we can basically say. So of course, every metal looks like a silver color only, the color of silver only. Am I right or wrong, guys? All the shining metals, they are having similar color to silver. Silver, how it will be bright in appearance. The same way like aluminum, you can take it, or you can take sodium metal, color difference and expose it to air. So like everything, if you notice it. But if you take, there is a non-silvery metals. There are 2 non-silvery metals. Anybody can guess which is not looks like that shining appearance, the same color like brightness. Anyone? Non-silvery metals.
Copper.
Yes, that is what. So that metals is called as non-silvery metals. So any other than these 2 you can take. You can take mercury, you can take silver, you can take any other XYZ. They all appear.
Sir, gold.
Yeah, non-silvery metals which do not have a similar structure, similar appearance of like silver. That is what? One is gold, another one is what? All of you.
Silver. Copper.
Okay. So this is what? That is why they are called as non-silvery metals. Please list it. Okay. All of you understand? Hello, Eresra. So
Yes.
the shine and brightness of metal surface reappears if they undergo corrosion. If you want to get back to the shiny appearance, so you have to rub with the paper. What is the paper we have to rub with, everybody? We have to rub with the sandpaper. So if you rub with the sandpaper, they will be getting back their shiny appearance. Okay, and you can take it here. The gold is used in designing of jewelries. You can see our Indian jewelries, most of the jewelries will use gold jewelries only. Why, sir? Due to their long-lasting luster. Of course, they are not having a silvery like luster. Why we are using a gold? That is also one of the important question. What is the main purpose of using the gold as a jewelry making? Because of least corrosion rate. Understand, all of you? Least corrosion rate means long-lasting. Long-lasting what? Long-lasting luster. The shiny appearance of gold, it will take many years to last it. That is the reason gold is preferred to use in designing of jewelries and all. And next one, if you take for example, metals like sodium, just imagine sodium, very few seconds is sufficient to last their what? Anybody? Last their luster within few seconds. You can understanding, everybody? So if you expose, suppose when you cut the sodium metal with a knife, it will show grayish color. But as soon as it is exposed to air, it will form a white coating on grayish color due to the formation of one oxide. What is that? Anybody can tell? Sodium oxide, because it is extremely highly reactive. When we cut the sodium metal, during cutting, please note it, during cutting or during cut, it will be appears to be grayish color, GREVISH, grayish color. But as soon as it is exposed to air, it will immediately react with what? Oxygen, and it will form sodium oxide. Now, Mr. Arun Kailas will say sodium oxide formula. And can you tell me sodium oxide formula, Mr. Arun Kailas? Pugal, sodium oxide formula, Pugal.
Sir, Na2O.
Very good. So Na2O. So sodium plus 1, oxygen is 2. If you crisscross, you'll get Na2O. Okay. So please light it. So that is what. So when we cut, what is the color of the sodium? Everybody? Grayish color.
Grayish
But
color.
it will be immediately react with oxygen and it will turns into what color? It will turns into
White.
Yes, please. White coating. Okay. The sodium oxide color is white. White coating. So please remember that. So this is what about the third property. Metals are lustrous in nature. Next. Fourth property. Fourth and fifth. I don't want to stress much time on this. This is all nothing they will ask in exam. But you are need to know. So metals are malleable. What do you mean by malleable? We all people knows. Not all. Generally metals are malleable. What do you mean by that? They can be hammered into what? Respond.
Thin
They
sheets.
hammered
sheets.
into thin sheets. That is what? Thin sheets is called malleability. The property of the metals which we people can hammered into thin sheets is only called as what? Malleability. So we can see that copper sheet, zinc sheet, iron sheet, lead sheet. We can prepare every metal except mercury, we can make it into sheet. But again, exemption is there. Sodium and again, exemption is there. Sodium and potassium. Understanding? Sodium and potassium, it is not possible. Now, sir, how much thin you can make? Do you all notice it? How many of you are at least one time, have you bought sweets from A to B? Your Tamil Nadu famous sweets, A to B sweets. Am I right? Yes, please respond. So there is a sweets called as silver coated sweets. Do you all remember? Have you watched? At least have you seen anywhere in the sweet shops silvery coated sweets?
Yes, sir.
Yes. So very expensive. Do you
Yes,
remember? The cost is too much of high. Of course, nowadays we are getting gold coated sweets also. 1 kg almost like 13,000 rupees to 14,000 rupees. 1 kg sweets. Extremely high cost. So actually they are coating with the original gold and original silver. But 1 gram of gold they can coat for 100 kg sweets. Do you understand, all of you? 1 gram of gold will be coated to more than 100 kg sweets, because that much thin sheets we can make it from gold. Highly malleable in nature. Extremely gold and silver are the most malleable metals. Please note it that point. Gold and silver are the most malleable metal. After that, aluminium. Understanding? So that is what, have you remember aluminium, we will use it in wrap up chocolates. You buy dairy milk. How many of you buy dairy milk? The chocolate is wrapped in the aluminium foil. Am I right?
Yes.
Girls, boys, everybody. You can see that. Medicines. How many of you buy the medicines? Aluminium foil. Am I right or wrong? Backside aluminium will be there, or else entirely it is packed in the aluminium. Am I right or wrong?
Yes, sir.
Yes.
Yes, sir.
Nowadays you can buy some little costly biscuits. Biscuits also wrapped in the aluminium foil only. So that aluminium, iron, copper, everything we are making into thin sheets, because that is the reason your house we are using aluminium boils, utensils, we are using copper utensils, we are using iron instruments, everything because of the property called as what? Because of the property called as malleability.
Malleable.
Because of that, they can depend upon the force they will turn into a different shapes. So who is having highest malleable? Everybody.
Gold.
Gold and silver. So please note it that. That is why silver sweets. Have you all, how many of you ate silver? Silver sweets by removing the silver layer? I think many of you ate. I also at the beginning I experienced silver. I received silver sweets like 1 or 2 from some people. I started removing that and started eating. After that only I come to know that it is good for our health to consume it. Then I start ate together with that. So it is a very minute layer. As our bodies need, silver is also a mineral is needed. So we people can have it. Nothing will happen. There is no harmful nature for our body. Is it okay, guys? Everybody? Yes, please. So nowadays, even gold coated sweets also coming, but it is very expensive. So you can all experience it whenever you get a choice to eat. You can. Okay. Yeah, Manikandan is saying something, Kaju Katri something. I don't know what else it is. So you can. Okay, guys. Now, next one. You can notice it, particularly now. Next property is very important. So the next property, most probably, I notice it. Basically, I'm having some Muslim family friends, like my childhood. So for their marriage culture and everything different from our things. And they will like their saris and the dressings and all is extremely even expensive than we people. So, and of course, nowadays, even for normal people also, everybody they are using for marriage and all, they are using very highly expensive dresses. So how many of you know girls have heard a word called as embroidery? Embroidery. Boys also might be heard. Embroidery work. Yes, just please respond. All of you?
Yes, sir.
Yeah. So embroidery work, if you notice it for saris, for mainly for marriage purpose and all, I noticed it in mostly these kind of jari thread. I think Muslims might be knows very well. That women's they will use mostly. I used to notice when I'm childhood, like my Muslim family friends, I used to notice that. So royal dresses we used to call that as. You can notice it. Any kind of these people like cine actors or these heroines or some other thing, or like generally even our marriages, that bride saree and all. Nowadays we used to like even boys also, bridegroom also, he is wearing as some kind of what is that we used to call as like what is that rice? It's not like a shirt and pant, something like a kurta till down it will be there, correct? Like a dress. What is that called as?
Sharwani.
Yeah, I don't know what is the name of it. So you can. So everywhere, this royal dresses, they're having a embroidery work with a jari thread. So this jari thread actually, it is made up of what? Anybody can tell? Yes, please.
Sir, silver.
Yeah, silver and mostly even gold also. Do you understand it? Yeah, as Sharwan is saying. So you notice, you might be notes NTR. Have you heard NTR? RR movie, Triple R movie hero, one of the hero. You might be heard. During his marriage, his wife's saree is 1 crore. So it's very, very trending by that time. So because of this is the work. So there is embroidery with peacocks actually. The entire that saree border is made with the peacocks. So completely made with jari thread. That is what a gold thread. That is the reason it is highly expensive. Almost 1 crore the saree cost it is. So that's what I notice it in many this Muslims marriages. They will be used that basically like for one border line. So that is what. So the property here which we are using, making a thread, jari threads is like extremely like a thin wires. That is what we used to call as the property called as what? All of you.
Ductility.
Metals are ductile in nature. So we can drawn into understanding many metals like copper, aluminum, iron, etc. We can be drawn into what? All of you? Drawn
Thin
into
wires.
wires. So that is what we used to call as is called ductility. So how much thin we can? You remember, of course, all the metals are not equal. Most of the metals are ductile, but ductility of all metals are not the same. Same way, malleability also. Majority of the metals are malleable, but all the metals does not have same malleability. Do you understand, guys? Everybody?
Yes, sir.
Yes, please. So that
Yes,
is what.
sir.
Now, for example, if you take gold and silver, they are actually most ductile metals. Again, same. Malleability also, who is most malleable? Silver and gold. And now also here, ductility also, gold and silver are most ductile metals. So do you know one fact? If suppose I give you 1 gram of gold, just 1 gram of gold, how much it will be? It is even not visible properly. Am I right or wrong? So the 1 gram of gold, you can make a thread up to 2 kilometers. Imagine that. How much? Without breaking. That is a word you should use, a word called as. Without breaking, you can draw a wire up to how many kilometers? Everybody?
2 kilometers.
Clear? So that is what you can make it. Even a thin gold wire was used for embroider royal dresses, which is what we used to call as jari thread. Olden days, from the king's time, many of our Indian kings, all the kings, like you can take Mughal empires, you can take Chhatrapati Shivaji, their caps or their dresses. You can see mostly you can notice the Chhatrapati Shivaji dressing style. It is not like shirt and pant. It will be something like something dress, like we can notice it. Yeah, copper is also highly ductile, but it's not more than a gold and silver. Clear, all of you? So silver is also one of the best ductile metal. So now, instead of jari thread, before and all, people used to use gold thread only. You can notice it basically. Now also that this heroines and all these heroes and all, for their, because of their surplus money, they can make it. But nowadays, like us people, we people are using silver thread as a jari material, but that is also very expensive. I am saying you. Nowadays, silver also 1 kilo 80,000 almost now with the tax. So it cannot be. So just I'm giving idea so that you people can remember future. If you see any, particularly girls, you can notice it during the any your relatives marriages and all, you can notice the embroidery works where it will be like it will be. So this embroidery works and all made with that only. So you can see that. So this is what the malleability and ductility of metals. What is the reason? Sir, yes, it's very funny. It's very nice. Good. What is the reason behind it? That is what we should make it now. So the reason behind both for ductility and as well as what? Malleability is noted due to the bond which holds the atoms, metal atoms. So that is the reason. So there is a bond formation. These bonds are very, very less rigid. So the metal atom changes the shape, like their position and the shape by applying the force. But application of force, they can change their shape. So that is the reason you can see they can easily transform into sheets. They can easily transform into thin wires. Clear, guys? All of you? The bonds are less rigid. The bonds are less rigid. What do you mean by rigid? Like a stiffness. So if they are rigid in nature, they will break. They won't be structured into sheets and as well as wires. So that is the reason they can change their the metal atoms change their positions easily, and because of application of force, they can drawn into thin wires as well as thin sheets. But you remember, all the wires does not have same malleability. All the metals does not have same ductility. Of course, most of the metals are malleable and ductile in nature, but that malleability and ductility is not equal. It's not same for every material. Do you understand, all of you? Yes, please.
Yes, sir.
Yeah. So that is what you people can remember that. Now, you can see next property, which is very well known to us. So already electricity chapter we finished in the physics. There is a metal we are using practical applications of heating effect of electric current. There is a metal we are using that because of extremely high temperature, almost 3,380 degrees Celsius, we are using as a
Sir,
film.
tungsten, sir.
Yes.
Tungsten.
Tungsten. Of course, there is exemption again here. So please write it. Metals have high melting and boiling points. That is the next property. Metals have high MP. MP means melting point and as well as BP, boiling point. Okay. So except some metals again. So there is a liquid metal. What is that having? Except except some metals. What is that, everybody? Mercury. If you take it mercury, which is having lowest MP. What do you mean by MP, guys? Melting point. Okay.
Melting point.
So remaining all the metals have high melting and boiling points because the particles are joined together with a strong force of attraction or weak force of attraction. Everybody. Yes, please. Strong force of attraction. So due to the strong force of attraction, all the metals except mercury, they are having high MP and as well as BP. Okay, guys, all of you, please respond. Now, there is another two metals who is actually liquid in summer season and solid in winter season. Anybody can tell? There is a two metals there. But of course, now present temperature, because of atmospheric pollution or many things, now they are normal winter season also, they are in liquid state only. There is a two metals who will be in liquid state in summer season and there is a solid state in winter season. Anybody can tell me? Even 9th class it will come. I know, I remembered. Yes, please. So there is a metals called as gallium and as well as cesium. Okay. So their boiling points is, sorry, their melting points is 30 degrees Celsius and as well as 28 degrees Celsius. Do you all understand now, everybody? Not mercury, gallium and cesium. 9th class, you might be noticed it. Second chapter when you are studying classification of matter, atoms, next, that is what, elements, compounds and mixtures. There is a right side column, orange color, light pink color, orange color tabular column will be there. There you can notice it. If you are reading, you can. If you are not reading, you cannot be. So 9th class physics, chemistry, it will be there. So these metals, summer they will be in liquid state. And you can see the metals, they will melt even when placed in our palm also. Just if you place in our palm, okay, so what will happen? Due to our body temperature, they'll start melting into liquid state. So they're having less than our body temperature. Even what is our general body temperature? Everybody, what is our body temperature? Inara 98.6 degree Fahrenheit. Am I right or wrong? Which is equals to 36 degrees Celsius. 36 or 37 will come. So their melting point is less than our body temperature. That is why if you put in palm, what will happen? They'll melt into what? Liquids. Clear, everybody? Please respond. All of you. So that is what is happening. Now, if you take the same way, tungsten. So tungsten is having actually highest melting point. So what is that, everybody? Almost 3380 degrees Celsius. Okay. So that is why it is used in designing of what, guys? Physics. Again. Yes, please. We are using designing of what? Designing of
Filaments.
Designing of filaments of electric bulbs and other heating devices. Okay. So this is what about the fifth property. Okay. So then from here, we will continue in the tomorrow's class. So they are having high melting and boiling points. Once this is over, then there is a few more properties and then we will start with the chemical properties of metals. So chemical properties onwards, it will be very interesting. So please kindly revise whatever we studied and don't get to the bed. So focus on work and we can concentrate and get back to the work just after 5 minutes or 6 minutes. Thank you, everybody. We'll meet in the tomorrow's class.